Today we're going to continue our study of ratios as we learn the differences between ratios and fractions. There's a lot of similarities between the two of them, but there's also a lot of differences that go on. So we're going to take and start off by jumping into your student pages, which you should hopefully have downloaded by now. And let me find that here. That is going to be, there it is, on my student pages, and you're going to answer this part here. You're going to write a story problem about a ratio, and then you're going to write that ratio in 3 different forms. Go ahead and take a second and pause the video to do that right now. So what I put down was that each lesson requires me about 4 hours of preparation. So that would be each one lesson would go to 4 hours. So my ratio would be 1 to 4. I've written it using the word 2, using the word 1 to 4, and it'll give me the fractional version of 1 to 4 and the colon version of 1 to 4. Now the next thing we're going to dig into here is we're going to start playing with our ratios a little bit more as we, let's see if I can figure out how to, no, we don't need to go down that far. Strange things are going on here. Alright, so we're going to play with the ratios a little bit more here, as you guys are going to use some color tiles, and you're going to take the color tiles you have and pull some ratios out of them. Pause the video, do that, answer the questions that go here. Wow, that thing kind of got messed up there, didn't it? So I'm not sure what the deal is. There we go. Maybe we can do it, make it look a little bit. There we go. Now clean itself up and answer the questions where you're going from this section down to that section right there. So how'd that work out for you? Now I'm going to take and do mine, and I'm going to say I don't have color tiles with me, but let's just say I ended up with 3 blue tiles to 5 yellow tiles. Then, if I was to make a fraction with that, that would become 3 over 5. That would be the fraction version. Well, it looks like question number 2 required me to have some tiles here, which I don't have actual tiles, but I do have some Unifix cubes, and that is what we're going to use. So you can see I've got my Unifix cube set up where I have a ratio of 3 blue to 5 yellow. The question wanted me to take and find number 2, to an equivalent fraction to the last fraction we made. So what do we need to do? We need to take and come up with a pattern going on that's going to be equivalent to those 3 to 5 ratio. And to do that, I'm going to take and put another 3 blue cubes and another 5 yellow cubes. And now, what do you have here? You've got a 6 blue to 10 yellow, and the 6 blue to 10 yellow is going to be an equivalent fraction that we can write, if I can find my pen where I left it, here we go, right here. So we can say that a 6 to 10 ratio is going to be, or actually they said to do it as a fraction, so it's going to be a 6 over 10. It'd be nice if they gave us some room to work on that fraction, is going to be an equivalent fraction to the 3 over 5 fraction. Now, if we wanted to, it says to make a part-to-part ratio and write the ratio in 3 different forms. So we're going to take and, I'm thinking that we're just going to do exactly what we've got here, because what we have so far is part-to-part. I'm comparing my 3 blue to my 5 yellow. There it is using the word 2. Here it is using the fractional form. Here it is using a colon. And now it says to do a part to whole. Well, what is the whole? That's going to be your 3 plus your 5. 3 plus 5 is 8. So we can say here that I have 3 blue to 8 color tiles total. That's using the word 2, 3 to 8 using as a fraction bar, and 3 to 8 using the word colon. Now it says make an equivalent ratio. It says write the ratio in 3 different forms, and hint, use strategies to create your equivalent ratios. Well, we already kind of did that, because the equivalent ratio we came up with right up here, that was my 6 to 10. So I could write 6 to 10 using the word 2. I can write 6 to 10 as a fraction, and I can write 6 to 10 using a colon. So there's the 3 different ways to do that. Now you and your friend, so I want to get there, whoever's in your table group with you, you're going to take and work together to fill out this top part here, where you're going to think about what some things are that represents a fraction and what some things are that represents a ratio, and where they overlap. What do a fraction and a ratio have in common? So go ahead and pause your video and work on that right now, please. Here's what I came up with when I did that. First off, I said that a ratio could be a part to part, or it can be a part to whole. A fraction is always a part compared to a whole. So that was the biggest difference I saw just right off the surface, is that a fraction, it's always a part to whole, while a ratio could be a part to part or a part to whole. Some other differences we're going to learn here shortly is that a fraction is going to represent a set numerical value, a part of a number line, for lack of better terms. And then while the ratio is going to be a set relationship pattern. So for example, as we saw earlier, where we took that 3 to 5, we changed that to be a 6 to 10. So you could say if that was your ingredients for chocolate chip cookies, you had 3 parts powder to 5 parts of chocolate. Yeah, I like that ratio. Well, that would mean 6 part flours to 10 parts chocolate if you wanted to double your size. We're going to jump back over to our slideshow here, because we have got some really cool stuff that we're going to pick up on this. Then we're going to jump down here, and here's going to be the next part. You've got a couple definitions you need to fill out on your worksheet. The first one, what is a fraction? Well, a fraction is expressed, a fraction expresses a number that is part of a whole. So for example, 1/2 of the circle, well, that 1/2 is a fraction. It shows how much of that whole we actually have. Meanwhile, a ratio is going to be a comparison of 2 or more quantities that are related. So we've got 2 apples to 3 oranges. They're similar, but they're also very different. So we have 2 or more quantities. Now, could this also be a ratio in the fraction? Sure it could. You have 1 out of 2 sides shaded. You have 1 of the 2 pieces of pie left. So there's definitely still some ratios. Ratios can be fractions, but fractions cannot always be ratios. So the 2 apples to 3 oranges, that 2 to 3 is not a fraction, because it's comparing 2 totally different things. It is not part of a whole. Now that should have taken and filled in these 2 boxes on your worksheets. Now we're going to scroll down a little bit further, and we're going to compare ratios to fractions and the differences between them. So we're going to jump back to our PowerPoint, which is, let's see if I can find it, get it to pop up here. There we go. So in the PowerPoint, it says a ratio is going to be a part to a part. There's a place for you to be writing this in your notes. And it can never be a fraction, because it doesn't compare anything to a total. So let's discuss that a little bit more. It can be written as a fraction. It says never be a fraction, but look right there, it's a fraction. It is written in fractional form, but it is not a true fraction, because it is comparing 2 parts, apples and oranges, not half of an apple pie. Okay, not part of a whole pie. Is comparing 2 separate things. So ratios compare 2 separate quantities. Meanwhile, a fraction is a part of a total, also known as a part to a whole, and sometimes can mean the same thing as a fraction. So here, the ratio can sometimes mean the same thing as a fraction. So here we got an example of 1 dog to 2 cats. Is that going to be a fraction, or just a ratio? That's just a ratio. Cats and dogs are different. Okay, so that's, you said that dogs make up 1/2 of the, or 1/3 of the animals in your house. Then you're comparing the dogs to all animals in your house. That would be a part to a whole. That could be a fraction. If you said 1/3 of the animals in your house are a dog, but 1 dog to 2 cats, that is just going to be a part to part ratio. The dog to total pets, that's what I just talked about, and that of course gave us that 1 to 3. 1 to 3 is a fraction, and 1 to 3 is a colon. So 3 different ways you could write that one as well, showing that a ratio can equal a fraction, but doesn't necessarily equal a fraction. And that should have filled up this box in your note package. Now let's dig into it even deeper. Now we're going to take and go and look back at our PowerPoint, and this time we're going to compare fraction to ratio another way. Here they say a part to a total or part to the whole ratio is a set relationship pattern. That's what you're going to write in your notes, not a quantity that is unchanging on a number line. So for example, 1 out of 2 can sometimes become 2 out of 4, or 3. In fact, it can always become 2 out of 4 or 3 out of 6. So you see the first ratio was 1 to 2. When you doubled that, that became a 2 to 4. And if you tripled 1 and 2, that means you multiply both the top and the bottom by 3, you're going to get 3 out of 6. Meanwhile, a fraction is a set numerical quantity. It doesn't change. You're not taking and increasing the pattern of the fraction to get equivalent fractions, although we do simplify our fractions, but we're not going there right now. We're taking and just looking at the ratios, saying that 1/2 can be graphed on the number line and it is unchanging. 1/2 is always 1/2 of 1 on the number line. So you got things that you can increase. Remember we talked about putting those chocolate chips in our cookies, making more cookies that way, or things that are constant. That should have taken and filled out this part of your box, your note paper. You should have drawn in the table here that we had and the number line here that we had as well. From here, you've got a couple things left to do. You have let me jump over to this one so we can see it where I've not filled it out. You're going to take and boom, boom. You're going to do your exit ticket where you're going to come up with 3 equivalent fractions. Okay, they're ratios but written in this fraction form, and then you're going to say list at least one difference between a ratio and fraction. So you're writing this out in words. You need to go back and look at your notes, see what you can figure out. And then when you're done with that, you get to take and play around in Math Playground. We're going to call it play, but it's actually going to be learning through play. And you're going to take the link. I will have this link for you right here in GoodNotes. Excuse me, not GoodNotes, in Canvas. So you can click on that and it's take you to the right place where you're going to take and use your understanding of equivalent ratios to play a game and see how good you can do. Make sure you get your work turned in. I'll see you in class.